Okay, so I wasn't sure if I was going to do this video, but here I am doing it. And there's a couple of reasons why. One is it is good information about what's happening within our vertebrates, but it also helps to revisit some phylogenetic notions that people might still be struggling with a bit. Okay, so within the vertebrata, it used to be thought that the phylogeny looked like this, that we had the amphibians, and then we had the amniotes, which included things like testudines, that's turtles, etc. And then we had this branch between synapsids, which became mammals. I'm just going to describe them as stem mammals. And diapsids, which diverged into, traditional reptiles, dinosaurs, including birds. When I say reptiles, I mean reptiles minus testudines. And why was this thought? Because amphibians and turtles both have a skull type where they have no postorbital fenestrae. And as such, we refer to those as anapsid skulls. So no extra holes behind the eye socket. Synapsids have one postorbital fenestra, orbital fenestra, and diapsids have two postorbital fenestrae. So skull morphology was a big part of this thinking, and also because a lot of turtles are found in water. So this idea made some sense. But since the revolution in being able to use DNA techniques to resolve phylogeny, our current thinking on this is a bit different. So it is still recognized that amphibians, which again includes frogs in the Anura, salamanders and newts in the Caudata, and our Sicilians, are all, these are all anapsids for sure, yes. And they share a clade. But now we think that synapsids, which again became mammals, or are still living synapsids, are all mammals, and diapsida, the evolution of the diapsida is a bit different. So you can always see that diapsids, which includes our traditional reptiles, which includes turtles, didn't quite branch in the same way. So we still have the advent of the amniote egg here, which divides our amniota, synapsids and diapsids, from amphibians. However, within the diapsida, we've got the testudines, we've got squamata, which are snakes and lizards, and geckos and a whole bunch of other things. just re-emphasize that testudines are turtles. We've got crocodilians, crocodilia, which includes caimans, alligators, crocodiles, gharials, a few other things. Then we get the I'll just say I'll do it this way, okay. Non-avian dinosaurs and aves, birds. Okay, so this tells a different story in terms of skull evolution, because here we've got synapsids. Here we've got, diapsids. But turtles are now thought to be secondarily anapsid. Which means being an anapsid in this story, anapsids are polyphyletic. And in this story, anapsids are monophyletic. Well, really, they're paraphyletic. Right? Because the common ancestor of all anapsids would have been back here, but we would have had to make this second cut here to remove the testudines. So here's a case of paraphily. Common ancestor has the characteristic, but not all of the descendants. So we cut here and here to form anapsida. That's paraphily. Whereas here we'd have to cut once here and once here to include all anapsids. Okay, so paraphily, polyphily, tetrapod, phylogeny.